have a right triangle with the leg measures of 6 and 8, we can easily find the measure of the missing side. The missing side in this problem is called the hypotenuse. The hypotenuse in any triangle, regardless of right or not, will be opposite to the larger side. In the case of right triangle, it will always be opposite to a 90-degree angle. So how do we find the measure of the hypotenuse? We apply something called the Pythagorean Theorem. How do we use this theorem? It's much easier than spelling it. All you have to do is take the square of both legs and add them together. Then square root the sum and you have the measure of your hypotenuse. Similarly, you can subtract the length of one leg squared from the hypotenuse and squared and take the square root of the difference to find the length of the missing leg, which is pretty simple. Some right triangles don't even need the Pythagorean theorem to find a side measure. There are two special right triangles that allow this. They're the ones with the angle measures of 30, 60, 90, and 45, 45, 90 degrees. In a 30, 60, 90 triangle, the sides are x, x root 3, and 2x, which are always opposite to these respective angles. If you know one side of a 30, 60, 90 triangle, you can find both the other sides. For example, if your x, which is opposite to the 30-degree angle, is 5, we can apply this value to our x and x root 3 and 2x and find their measures. The other special right triangle, the 45, 45, 90, is similar. In this one, the sides are x, x, and x root 2. We solve this the same way as in the other special triangle. If we know one of the sides opposite to 45, we automatically know the other congruent side. Now we just place our value, which is x, in place of x root 2 to find the hypotenuse, just like in a 30, 60, 90 triangle. How do we find this side of a right triangle that's not special and we only know one of the sides? We apply three functions: sine, cosine, and tangent. Here's a joke. Why did sine and cosine go to the bank together? Because they wanted to open a new bank account in which sine was the signer and cosine was the cosigner. Haha. Sine is one way to find a missing side. We use sine when we have one angle and the one leg either opposite to it or the hypotenuse. If we have the opposite leg given as 5 units with a 68-degree angle, we set our equation as sine 68 equals 5 over x, with x being the hypotenuse that we are looking for. Now we solve for x like a normal equation. We multiply both sides by x and divide both sides by sine 68 to get the x alone. Now we need our calculator to find the final result. We have our answer now. The hypotenuse is about 5.4 units long. Remember to round the answer to whatever place you are told to. We do the same thing if we are given the hypotenuse and we have to find the opposite side of a given angle, which is the opposite of what we just did. Let's say the angle is 72 degrees and the hypotenuse is 9. We set our equation as sine 72 equals x over 9. All we have to do in this case is multiply both sides by 9 to get the x alone. Now we enter 9 sine 72 into our calculator. We get about 8.6 as our length of the opposite leg. An acronym for sine is SO, which stands for sine equals opposite over hypotenuse. What if we have an angle, an adjacent side, and the hypotenuse? We use cosine because we can. Get the pun? The cosine of the angle is the adjacent side over the hypotenuse. Let's set our angle to 24 degrees and the adjacent side is 4. Our hypotenuse will be our x. We set up our equation just like last time, just instead with our cosine ratio. We write out cosine 24 equals 4 over x. We solve for x like before and enter it in our calculator, getting 4.4 as our side measure. If we have our hypotenuse, say 6, and an angle is 38 degrees, then we can find our adjacent side. We set up our equation as cosine 38 equals x over 6, and as always, solve for x. We get about 4.7 as the adjacent side's length. An acronym for cosine is CA, which stands for cosine equals adjacent over hypotenuse, CAH. What do you call a man sunbathing on the beach? A tangent, get it? Because he's a gent who's tanning? Anyway, we use tangent when we have a given angle and we need to find its opposite or adjacent side. The tangent of an angle is the opposite side over the adjacent side. Say our angle is 69 degrees and its opposite side is 12. We will set our adjacent side as x. Our equation will be tangent 69 equals 12 over x. As always, we'll solve for x by getting it alone and enter it in our calculator. We get 4.6 as the length of our adjacent side. Now, say our adjacent side is 2 and our angle is 78 degrees. To find the opposite side, which is the opposite of what we just did, we set our equation as tangent 78 equals x over 2. We solve for x and we get our 9.4 as our opposite side. Our acronym for tangent is TOA, T-O-A, which stands for tangent equals opposite over adjacent. So far we've learned about sine, tan, and cosine. Our grand acronym for all three is SOHCAHTOA. TOA. We've already learned what SO, CA, and TOA mean. When we put them together, we will never forget which ratios are for which functions. So what do we do if we have our side measures given but without the angle measures? We use the inverses of sine, cosine, and tangent. Using the inverses is just like using the normal functions, except for a step at the end. For example, let's use cosine. Say our adjacent side is 6 and the hypotenuse is 9, and we have to find the missing angle. We'll set up our equation as cosine theta, which is the same as x, which we use for angle measures in trigonometry, equals 6 over 9. Now to solve the problem, we use the inverse of cosine. In our calculator, we'll type in second cosine times, in parentheses, 6 over 9. We get our angle measure as about 48.2 degrees. All the inverses are like this. We would do the same equations as before and use the inverse of the functions to find the angle measures. Abiding by the speed limit is a law. You know what else are laws? The law of sines and the law of cosines. Now, breaking these laws won't send you to jail, but you'll probably fail your math test, which is, you could say, equally worse. We'll start with the law of sines. The law of sines states that the sine of an angle over its opposite side is equal to the sine of another angle over its opposite side in the same triangle. This applies for non-right triangles. What do we need? what we need to use the law of sines is one angle, its opposite side, and the side opposite to the angle we're looking for. Let's say we have an angle measure of 70 degrees and its opposite side is 7 units. We'll make the side opposite to our missing angle 4 units. Now we set up our equation as sine 70 over sine 7 equals sine theta over 4. We cross multiply to get 4 sine 70 equals 7 sine theta. Now we divide both sides by 7 to get sine theta by itself. We now use the inverse of sine to get our angle measure, which is 32.5 degrees. We can use the law of sines to find a missing side length as well. Let's set our first pair as 29 degrees and its opposite side is 12 units. Now the missing side will be x and the opposite angle will be 67 degrees. We'll set up our equation as sine 29 over 12 equals sine 67 over x. Cross multiply to get x sine 29 equals 12 sine 67. Now we'll divide both sides by sine 29 and put it into our calculator. We get 22.8 as our side measure. This law states that one side squared is equal to the square of the other sides added together minus 2 times the other side measures times the cosine of the angle opposite to the first side. It's kind of like the Pythagorean theorem but for non-right triangles. Like the law of sines, we can use this law to find both angle measures and side lengths. Let's look at the missing angle first. The opposite side to our missing angle is 90. So 90 squared equals 57 squared plus 110 squared minus 2 times 110 times 57 times the cosine of theta. We'll solve this like a normal equation and get cosine theta alone. We end up with 7,249 equals 10,540 cosine theta. We'll divide both sides by 12,540 and apply the inverse of cosine to find the angle measure, which is about 54.7 degrees. Finding a missing side using the law of cosine is similar since we have the same format. We set it up as x squared, the side we're looking for, equals 7 squared plus 10 squared minus 2 times 7 times 10 times the cosine of 48. In this case, we can directly plug this into our calculator and to give us the answer. Doing so, we get 7.4 units as the length of our missing side. So today we learned about the Pythagorean theorem, which can be reduced to a squared plus b squared equals c squared. In addition, we reviewed the special attributes 30, 60, 90, and 45, 45, 90 triangles have that help us find side measures. We also went over sines, cosines, and tangents and their inverses to find side and angle measures. Don't forget the helpful acronym of SOHCAHTOA. Finally, we went over the law of sines and the law of cosines, which also help us find angle and side